Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is Jeffrey Hawthorne. Give him a nice round of applause. We can't hear you, but go ahead and do it. Just clap in front of your screen like a crazy person. Anyway, so thank you for joining us. Sorry that we've been having a bumpy schedule on these things. Hopefully we'll have some time to do some more 2D episodes at some point, but it's just been really busy at work for me, and evidently even busier for Phil, because Phil is not here again today. But fear not, we will try and get things back on schedule. So let's just get started on this thing and do some plant stuff. Stand by. No, what are we doing? Okay, main screen. All right. So in our last episode, we got to the point where we were generating a randomized solar system. We have planets that all they all have their own colors. They have their own little trails that match their colors. We can go ahead and look at one of the planets here. Maybe it will let me look at one of the planets. There we go. So here's it cruising around. We have a basic texture map, which all the planets share, but we did something. So wait, I don't even have. Oh, trail. Okay, planet. This is what I want. So this texture map is based on a shader that I had made earlier called Palletized Color. And you actually have, there's a link in the description now for the last episode stuff, so you actually have this shader if you want to play with it now. We're actually going to make a couple of minor modifications to the shader probably this episode, but the main thing I want to do this episode is basically make it so that instead of having just one texture map that all the planets use, we want to have several texture maps that all the planets can use. What we're going to do. So, first of all, I want to go through this shader real quick, because I just threw it in last time, and we didn't really talk about it, and I just want to kind of expose you guys to shader language. I know this is new stuff. It's not new material from a standpoint of like shader stuff has been around for a while, but this is new stuff as in we haven't covered it on the show before. And so shaders are defined. Some of this is Unity's language, and some of it is actually CG code. This is actually a CG shader, which means that we could basically take this part of the code here, and with the exception of anything that uses a built-in Unity thing, like Unity Matrix MVP here, this code would basically work in a shader for whatever engine you wanted to work with. We additionally have this other stuff here that's designed for Unity. This basically defines the properties that are available in the inspector. So when we have a material that uses this shader, we have three variables: color, main text, second text. So we have color, main texture, second texture here. And those descriptions are here, so we could change this to say something completely bizarre, and it would just totally say it on there. There's no magic to this. It's just defining variables that are available there, and then they're redefined here, but they're actually Unity's automatically pulling the data from here and putting them into the appropriate functions here. And what this shader does is it's very basic, and it says CG code, not Unity. Surface Lab, Shader Lab, although we may actually switch it to that for reasons I'll show you in a moment here. But basically, what this does is you get this is the main thing that it's doing. This just gets the vertexes in the right places. This and the UV coordinates set up properly. Like this one here lets you. Wait, which one is it? So position, yeah. So the UV transform text here. This is a Unity thing that basically makes it so that if we change the offsets, they actually work. So like if I just create a sphere real quick, and we put planet texture on it, and we look at the sphere somewhere in the scene. If we do the offsets on these, like 0.5, it actually changes the texture offset. You can get away with just doing text chord, but without a transform on it. But if you do that, you won't get these offsets working. And the main reason I want the offsets is actually because the reason I made this shader in the first place is I was playing around with palletized textures. And what this shader actually does is, based on the value of texture 1, it grabs a color from texture 2. And where it samples from is designed so that you can just do like a very small texture. Like we just did this big square texture here, but it basically reads diagonally down here. So if you just have a very narrow texture, you can basically read down that way, or if you have a very narrow texture this way, it'll read down that way, and it'll just work. But basically, as you progress down here, so values that are black on here will be this blue here, and then as you progress down, there'll be gold stuff, and then as you get higher and higher, you'll get to white from this very small line of white, which we don't have on our example texture here. But you can see the blue sections and the orange sections. We were trying to create like oceans or kind of a planet look. But the reason I had it set up this way is actually so that we could change the offsets originally. So, because if you offset the texture, you can actually create some really interesting animation where things fill in and out. You're gonna have to use your imagination a little bit on this, on the animation, because it's, unfortunately, unlike a lot of the controls on Unity, we can't just drag out the value here, because otherwise you'd see it would kind of scintillates. It basically just makes all the textures kind of move along the what would you call it? It's like a height map. Well, that's not the right term I wanted to think of. Yeah, like those maps that you use for topography. Topographical map. That's what it's like. It's like cycling through that and kind of showing the change in elevation. But yeah, that's the reason I made this in the first place. And so the real magic of this one is right here. And all this says is it returns text2D. This is a function that gets the texture information. And it does it based on the second texture and the transformed main texture. And then, I don't know why it has this third one. Why does it have that the third time? Second text, transform text, second text. I don't know. It has to be there for some reason, I'm sure. And then we added on the last episode times color. All that does is it just shades the result with whatever color. It just adds a tint to that. And so we added that color information. And the main reason to do that is so that we actually could use our color information still. Now, the problem with the shader right now is it's actually full bright. It doesn't do any calculations for lighting. And the code for that is a chunk of it. For CG is a chunk of code because you basically have to tell it how lighting works, and you have to get all the lighting information into it. The other way we could get around doing all that is if we used Unity's Shader Lab system and syntax. They kind of break down shaders into components that are at a higher level, so they'll be like instead of just straight color output that you have to calculate all the lights for, it'll have like a color component, and it'll still do lighting and shading other than that color component. The color component will just determine the final pixel color before being processed for lighting or shading. And so as I said, we might go over that on this episode, but I'll probably start with something a little bit more focused on generating a new texture using purlin noise, and then we'll probably explore that if we have time. I do want to switch it to that so that we actually get lighting, because as I said, it's kind of dumb that we lost our lighting on this. Like if we go to the scene, we can make a pretty quick comparison here. If I just pick a planet, let's look at a planet. So I got this planet here. If we were to change the texture to just, if we were to change the shader on this to, say, just diffuse, you can see that, well, maybe you can see it. I don't really see any shading on there for some reason. Well, maybe that's a tough color. Do we have our star has a... No, we don't actually have... Oh, wait, we do have a point light. Here it is. Maybe it's not going far enough? No, it seems like it has a pretty long range. Here, let's just look at one of our planets. This one that we changed again. And let's pause it. Let's do that. So if we take the point light and we disable it, yeah, it didn't do anything. Why is that? I'm going to actually change the... It's just weird that that didn't just work, but I'm going to just try it real quick. If we go to planet here, and we change the shader at this point, and we hit play. Are we getting shading? This may be why we didn't notice the last time, because we weren't getting shading before anyway, and I don't really know why. No, now we're getting shading, it looks like. Pause. I don't know. Let's increase the intensity, increase the distance. How about, like... I'm gonna duplicate this point light. This is weird. Yeah, that's not being lit at all. Unless this is like not a valid value or something. 50. Alright, well...
The point light isn't calling anything, is it?
Calling mask.
No.
Yeah, it should be everything, right? Yeah.
Is it the color that's being applied?
What do you mean,
the
like...
material itself?
That, do you think that would affect that? I don't see why it would, but at the same time, I'll just go ahead and change this to white and see what happens. Let's get rid of like one of these lights. Yeah, it's totally not shading for some reason. Oh wait, I know why. Duh. It's because we're in the editor view. There we go. That was me being dumb. Alright, so normally in editor view it doesn't do shading anyway. You'd have to have it in game view to actually notice it. So if you click on this, it actually gives you the proper shading. So we can now get rid of our point light here. Oh, we have no point lights now. So I'm going to hit play now and see what we got. So now you should see that all the planets will actually be shaded. Pause, whatever. So yeah, there's shading. You can see that. But if we were to change this back to, again, the other shader again, which is under pushy pixels, palletized color, you can see that it's flat shaded. So anyway, we might fix that. Sorry that took so long to actually look that up, but maybe this will help someone who's trying to figure out why their lighting's not working in an editor. So what are we doing? So let's look at making a let's look at making a texture map dynamically. Let's see what we can do here. So we're going to create a C# script. We're going to call this random texture. May not be the best choice for it, but I think it'll be a good enough name. And all we're going to do here is on start is we're just going to generate a texture and apply it to our material. So how are we going to do that? So I believe if we go into the mathf library, there is now built into Unity a purlin function. Yep, there is, purlin noise function. And this takes two values, an x and a y, and this represents what offset within the purlin noise function, which is a continuous function, we go to. And so you can basically randomize that to get different looks to your purlin noise. You can basically add a random value to it and you'll get something. So now purlin noise is, if I'm not mistaken, it's continuous, and at regular intervals, specifically at whole numbers, it basically, it doesn't loop, but it ends in a way that can be looped. I don't know. We'll see what actually happens with this. We'll probably find out that I'm totally wrong on how the purlin noise function works in here, but I think we can create a looping texture very, very easily, just as long as we keep the left-hand side on an integer value and the right-hand side on an integer value, and same with the top and bottom. So what this actually returns, purlin, it should just return a value. So mathf.purlin noise, it just returns a float. That's all it returns, and that float is between 0 and 1. And it's based on what position you choose in the X and Y. So what I'm going to start is we're going to create two offsets, an X and Y. And I'm just going to create variables for them for right now so that we can see what we're doing. Int X, int Y. Actually, I'm going to call them X offset and Y offset, because I may be using X and Y for my iterative variables. And we're just going to make these equal to random.range, and I'm just going to do for right now 0, 100, and we will do the same thing for the Y offset, and this will actually give us an integer value between 0 and 99, and that's what we actually want. We want these to be integer offsets. As we said, we want to kind of begin and end the function on an integer, and then just pull the values from in between. So so let's create a variable up here for the resolution we want to make this texture at. So public float, actually int resolution, and I'm going to default that to 64. And this will assume a square texture map in all cases. We could break it out into separate things, but I don't think that's going to be necessary for what we're doing. And so what we're going to do is for x equals, for int x, we got to declare it equals 0. X is less than resolution, the lowercase resolution. It doesn't want to autocomplete for me anymore. And x plus plus. And then we're going to do the same thing inside this for int y equals 0. Y is less than resolution, y plus plus. So this is iterating horizontally and vertically. Oh, thank you. The code. Yeah, thank you. So, so what we're going to do is we're going to sample from the purlin noise based on our initial offset plus the percentage of the way across the resolution. So what that means is we'll do something along the lines of, so we're going to need to create a new texture first, I think. So let's do that here. Texture 2D equals, actually, is there just a texture? There is. I think we'll try texture 2D equals, texture 2D text equals new texture 2D, width, height, format, map linear. All right, I think we just want the width and height, so we're just going to set it to resolution and resolution. And what we're going to actually change is if we do text.pixel, so we have get pixels and get pixels 32.
32.
You want to do the 32 because it's faster?
Mm-hmm.
All right, cool. So we also have set pixels, which is what we're actually going to be using, but we'll use set pixels 32. And what this takes is it takes an array of colors. So we're actually going to generate that array of colors first, and then we're going to do the set pixels 32. So I'm going to just set this aside and comment it out. It's not even the complete phrase, but I just want to put that there so that we know what we're doing.
There's also a get pixel bilinear, which is kind of the opposite of what you're going to be doing with the purlin noise.
Yeah. No, get pixel bilinear gives you a filtered thing. The nice thing about purlin noise is it's already filtered because the function actually generates based on subfloat well, not subfloat, but like float accuracy. So it basically has bilinear filtering, quote unquote, built in. Because we could sample it like any rate. We could set this number really as high as we wanted it. Well, there's going to be a precision loss at some point, but realistically, you're not going to have more than, like 2048 for a texture anyway, because most devices don't like higher than that. I mean, computers can do higher than that. What's the max on a good graphics card these days? 8K? 8,000 something? 8,192, something
My
like
good
that.
graphics card, I think it's probably a lot higher than
Wow,
that.
really?
But I'm not positive.
That's just crazy. We just throw this stuff around now. All right. Anyway, so we're going to create an array of colors because that's what setPixels32 wants. That is what it wants, right? 32. Yeah, color 32 colors. So we're going to create a. So each one of these. I'm going to do it as a list just so that we don't have to. Actually, no, let's not do it. Let's do it as a. Let's do it. Yeah, let's do it as a list. Public. I'm lazy. So we're going to need system using system dot collections.
Then you're gonna have to put it back into an array, I think. When you
Yeah, there's a conversion method for that though that makes that really easy. So system dot collections dot generic, and what we're going to do is we're going to create a.
I know there's a method from array to list. I didn't know there was one from list to array.
Yeah, there's you can initialize a list with an array, and you can also do a toArray command on a list. So, so list of color 32s called color list equals new list color 32, and so this is an empty list now, and so we're going to add to this list the values that we need. So what we will do is we're going to create a color 32 color equals new color 32, and byte data. That's horrible.
That's why it's fast.
No. All right, so that's fine though. So this wants a value between 0 and 255 integer basically, but it's not actually integer, it's byte, but that will convert nicely, I think. So we'll see how this goes. We can always fall back to color because we're only doing this once, but yeah, in general, when you want to do this stuff, you want color 32 is a much faster operation. Though we're probably making it pretty slow with the lists here too. We'll see. We'll see what happens. So we're going to do new color 32, and so the value is going to be across the board. We're going to do, let's actually create another temporary variable. Float value equals mathf.purlin noise, and we're going to use x offset plus x divided by resolution, the lowercase resolution that's not showing up for some reason. And the y will be the same type of thing. It'll be y offset plus x y divided by resolution. And that there it gave me the autocomplete. Yay. I'll take it.
What part had to be whole numbers to make it?
So what has to be whole numbers is the value at the far left, value at the far right, the value at the top, and the value at the bottom, which this, given that the integer, the first value is going to be 0 on here. And actually, yeah, so it actually should be resolution -1. Because at the final value, x will be 63, right? Because it'll be less than resolution here. And we only want 64 total values, so there's a 0 value. So the 0 values, x is 0, and then on 63, this will evaluate to 1.
Should it be over resolution -1 or over resolution -1?
The latter one,
okay.
Which is what I'm doing right now. I think that's what you were saying, right? All right, so this maintains the offset. This gets evaluated first because it's division, and then so this is the final evaluation here. The first thing is under brackets because we want this to actually be evaluated before we do our division.
We could take that out.
We could?
Resolution -1, keep a separate variable so it's not calculated.
Oh, yeah, that's true.
64 by 64 times.
Sure, why not? Let's do it. Private int. Actually, I guess we could just do it right in there. Yeah. So, int res -1. This is a very, very... This really doesn't need to be... sorry, res -1. This is an optimization. This is not much of an optimization, honestly, but resolution -1 saves us a subtract. Well, it saves us several subtracts. It saves us a whole bunch of subtracts, but they're subtracts. Who cares? Res -1, and we don't need the brackets anymore. And res -1.
And it's only done at the beginning of the
Yeah,
program.
yeah, it's only
It's
one
not a big
time.
deal.
Just affects load time, which sometimes is a big deal. So color equals new color 32, and what we're going to just do is we're going to use value. Wait, sorry. This value is between 0 and 1, and color 32 wants it in integer format, or in byte format rather. So what we actually want to do is the integer value would be
Multiplied by 255.
yes. Int value equals value times 255. And that will work, right? Or do I have to do 255 point? I'll do 0.0 just in case.
No, that should work.
This should
And
work.
You actually
All right.
want it as in. You might have to typecast if
We'll see.
values afloat.
We'll
So
see
you
what it
might have to
complains out.
typecast.
We'll see if it complains. So int value. So this is red, green, blue, and then alpha we're going to just set to 1.0f, or sorry, 255. Is that right? Yeah, probably. We're probably still going to have to type text too because those are bytes. So
Just remember, if we don't see anything later,
what do you mean? Oh yeah,
then it's 0.
then it's yeah. So this gives us a color. Then we're going to add our color to our list here. So we're going to do color list dot add, and we're just going to add our color. And then at the end here, for some reason I deleted it, but what we're going to do is we're going to take our text dot set pixels 32, and we're going to feed it in our color list dot to array. And theoretically, this will give us a texture. Now, we still need to actually do something to this texture to actually see it. So what we're going to do is I'm going to set our main texture. So renderer dot main dot texture. Sorry, renderer dot shader. No, material. There you go. Renderer dot material dot texture.
main texture.
We'll do main texture, yeah, and that's settable. So we'll just do main texture equals
Or are we going to have a different texture for the
text.
purlin noise?
Oh, this is just to see it at the moment.
Yeah, yeah.
You also, I think you might have to do text.apply
Dot
after
apply.
After set pixels.
Oh yeah, probably. Text dot apply. Good call.
I think that's the step that actually takes time.
Yeah, yeah, probably. Render dot material dot main texture equals text. So does so it wants actually just a texture, not a texture 2D here. That's interesting. I think texture 2D is this is probably going to work. So
I'm
we'll see how
pretty
this.
sure that does.
Yeah, we'll see how this goes.
I think that will ask you to typecast the solution.
It probably will, but let's just see what it does, and then we'll fix whatever errors. So let's fix our errors. Yep, you're right. So we have to typecast this float to an... Wait, we don't want to typecast this
The
float to an
entire
int, though.
thing.
Yeah,
Put parentheses on
Okay.
it.
Over the entire
Yeah.
thing and put.
int. And we have to put this in parentheses too, right? Yeah. Save, so that solves that one. So this one was complaining about our values here, and I think it's because we need to typecast them to bytes. I guess we could just,
put it
yeah,
there.
let's put it there. Let's do it byte, and then let's change this to byte. Save. And we're done. Yay. All right. So now what we're going to actually see is if this actually works. So I'm going to create a sphere of some kind. I'm just going to create a sphere. It's just going to be this stupid sphere here. And we're going to attach random texture to it. and we're going to hit play, and then we're going to hit pause, and then we're going to see if it has a texture. And doesn't look like it does. So let's see what happened here. Yeah, I don't see, or is the texture just gray? Hold on. I think the texture ended up being just gray, so we've done something wrong. So if I don't have this script turned on, why do we have this animation taking up so much space? And let's get rid of that preview. So if we turn off random texture and hit play, yeah, it still says none texture. So it's definitely assigning something, but the values are not what we expect them to be. So let's figure out why. So first off, let's just dump the values that we're getting out of this. So debug.log value.
And we're calling the byte int value.
Yes. So all these are coming in at basically the same value. So obviously we have something wrong right at that point. So yeah, that's all really dumb. All right, cool. So x offset plus x divided by res minus 1, y offset plus y divided by res minus 1.
Oh, x and res minus 1 are both integers, so it's not doing floating point division.
You were correct, sir. So what Jeffrey was just saying is this is an integer, and this is also an integer, which means it's doing a non-floating point, which means it's going to get a very... it's going to get the same value for every value of x, and the value is going to be 1, I think. Except for the first value might be 0. Maybe. So all we have to do on this is just make sure that we cast this to floats. I think we only have to cast one of them, but I'm going to cast both just to be safe. Whoops.
We could probably make res minus 1 a float instead of casting it also.
Good point. Let's try that. Float. Save. Alright, so now if we hit play, and we look at our thing, so we're still getting... No, we're getting some variation in values now. So we definitely got some variation. You can actually see... Huh. Not a lot of variation, is it?
Click on it and look at the texture. It might be easier to see.
Yeah.
Because it's wrapping at the top, and it looks like the top is where most of the variance is.
So yeah, we're getting this hill thing.
Looks like we're zoomed in on the purlin.
Yeah. So what we're going to need to do is we want to get more variety so we can quote-unquote zoom out on it by making the range that we sample from larger. And the way we can do that is we can... What we can do is we can basically take res minus 1 and divide it by, well, let's not do res minus 1. Let's just do, yeah, res minus 1, that's fine. So float scaled res equals res minus 1 divided by scale factor. So I'm going to call it scale. We don't have it yet. We're going to create it. We're going to do public float. Actually, we should probably make it a int scale. And let's see what this does if we plug it in here and here. So if we hit play now, yeah, look at our planet. Okay, so we lost the continuous nature. Did we actually even have that before? Here, I want to just double check to see if it was even working in the first place. I'm just doing this as a very basic debug thing here. I guess I could have just set it to 1 as well. I don't know why I didn't do that. So on this one, yeah, no, we still have, it's not continuous. Dang it.
Do we have int at all of the borders?
Let's find out. So let's just debug log value plus So all we're doing is just printing out these values. I'm actually going to make a comma there, so there's nice commas between them.
I think you're going to want to put parentheses around the x offset plus x over.
Oh, yeah. Yeah, we are. Thank you. So we need to do that, and we need to do this. Save. Let's see what we get. So if we look at our console, so it says 4073, so that's an integer, and then the bottom is 3972, that's integers, so yeah, those are integers, but it's not, yeah. Maybe it has to be the same offset. Let's try that. Just gonna comment that for right now. And we're just going to change this to this, this to this, this to this, this to this. Save. Hit play. Garcine, nope, still has a seam. And they're definitely whole number values. Yep. 91 and 92. Dang it. Well, let's not worry about that just yet. Maybe we'll cover that one in a future episode. Let's just see if we can get something that looks more like a planet. Let's go in here and change the scale on the random texture to, let's do 10 and hit play. We'll see if this actually looks a little bit more like, there we go. Now it's starting to look like a texture map of some kind. Is it? Wait, is it? Does it have a seam? Probably does. I'm just not noticing it. No, actually that might be working.
Maybe at certain multiples it
Yeah.
works. So
Weird.
what, in the debug log, what did it land on?
The debug log, it was 38, 38 to 48, 48, as we'd expect. Some value between 10 away from some other value. Let me go back to where we had separate X and Y offsets real quick. Okay. Too far. And I don't want these logs anymore. I'm just curious if we have what we got here. Alright, so that was, again, I forgot to change this value back. So inspector, wait, no, scale is 10. Am I not doing the calculation? No scales there. Am I using scales? No, I'm not. Went too far back. Save, play. So this works pretty good, it looks like. Let's see if we do like 1, how it looks.
Oh, maybe that's the problem.
Yeah, 1 definitely doesn't look good. What about 2? Unfortunately, we only do this during start. Well, it's fortunate because we don't want to actually do this every frame. It'll bring even my computer to a halt, probably.
Especially if you have the debug log still in there.
Yeah, that one appears to have a very clear one as well. Maybe it's just, maybe you just have to have a certain amount of scale. Here, let's try
9.
Try 9. All right, we're gonna try 9. 9. Scene. Oh yeah, that doesn't work.
So at 10, okay, try 19, and then try 20.
All right. How are we doing the division here? Res minus 1 divided by scale.
So it's x over res minus 1 over scale.
Maybe it's just harder to notice.
There it is, I think, isn't...
I think it's just harder to notice. I think it's actually not working. But let's put this up to like 200 and see if we get something that looks higher resolution than our previous stuff. God, it's not very... Oh, it's because it's 64 by 64. I'm not even thinking. Let's make the texture resolution way higher. Let's go into this thing and make it, I don't know, 512. Hit play. So, is it possible to see a thingy? I don't see a thingy. Now, if I make it not 200, if I make it like 199, I'm curious if we'll see an obvious thingy or not. We're using really technical terms here today, thingy. I don't see a seam, but you know, there's probably one there and I just can't see it. Alright, we definitely don't want to do 200 though anyway.
Or
So.
back to 10, I want to see what it looks like with the high resolution
Alright.
at 10.
So 10. This is what it looks like at the higher resolution. That looks like that might be the line right there. Oh no, there it is. That's the line. Alright, so if we hit stop here, so this is where the line will appear always, theoretically. So let's see if we can notice it at... So 10 definitely was not working then.
Could have easily gotten it from there. It's on the x-axis, I think.
Huh?
If you hit one of the...
Oh, yeah.
Oh, if you hit like the cones, then it aligns on that.
Oh, yeah, you have to have the cone there first. There we go. So if you hit play, we'll see the seam right down that middle line. No, it's a little bit off.
Wait, click. Is the sphere rotated?
No. Should it actually be across this line? Maybe we're actually doing something wrong then. Maybe.
Oh, change it to orthographic.
Orthographic's funny because this is a trail of some planet in the background that happens to be the same size as a planet. That's funny. It's weird. You'd think that it would be right there.
Do they texture?
I don't know. I really don't.
offset on
I have
the-
no idea what they do on theirs.
That's weird.
So the built-in primitives are actually so messed up that it wouldn't surprise me at all if so yeah, so we can definitely tell that there's a line there. Let's do 50 and see if it's really obvious still. Probably is. Oops. Yeah, it's obvious. There it is. Getting some weird hole things, you know. I wonder what that is.
That is the technical term. That's why we both said it at the same time.
What's going on there? Oh, we're gonna just live with it for right now. So we can actually still use our other texture map that has the not the illumination, but the yellow sun uses an illumination map. The one that we have on our planets here. So if we go to prefabs, planet, and actually, something I'm going to do is random texture. Yeah, this will be fine. So let's actually put this randomization in here. So we're going to put this on a planet, and we should also probably put it on the moons too. And I'm going to modify our create solar system thing to have an additional variable here, an additional couple variables. So let's do public int texture scale is what I'm going to call it. And we're going to default this to, actually, we're going to do it min texture scale. And we'll default that to what looked good. 10 was probably pretty good, so let's do 10. And then public int max texture scale, and we'll set this equal to 100. And actually, let's not do that. Let's do 30. And this will actually be planet texture scale. And then on the moons, we will also have these variables, but we're going to call them moon and moon respectively. And these ones we're going to actually set to like between 50 and 100 because it'll make them look like they're filled with craters as opposed to having kind of like a smooth surface. And then finally, we're actually going to use those variables somewhere. So set up celestial body is probably the place to be. We're going to get the planet instance dot get component. What do we call this? Random texture. There we go. Random texture. Dot scale equals. Oh wait, we have to feed this in.
What if we created one large purlin noise texture and then shared it, had all of the materials share it, and they could change the scales based on the local scale and offset? We could randomize the local scale and offsets on the materials.
Yeah, we could do that
that
too.
each are using, but then that way they would share the same texture, so we'd only have to generate one giant texture. And
I'm gonna write that down. I'm gonna mention that.
That could help with the draw
Consider
calls also.
it won't help with the draw calls, especially if we're still changing the color on anything. And I think texture offsets still mess up your draw calls if you change them between two objects, because the moment that you change them, it creates a new instance of the shader. If I'm not mistaken, not the shader, of the material. Consider creating huge.
Yeah, I think it does.
Huge. Consider creating huge purlin texture and then looking at a portion of it for each planet. I'm just going to put that in as a note.
That's when we can use mesh colors, though.
This is true. Like,
then we would still cut down on draw calls. If we use mesh colors, then we could leave the material alone.
so this is our moons and this is our planets, so we can actually just do it out here. That's what I'm going to do. So the moon texture scale, random dot range moon texture scale max moon texture scale +1, and we do the same thing here for the planet. Whoops. Except for we use planet and we use planet scales. Oops. So theoretically, if we hit play now, if we don't get any errors, which we didn't, each of our planets now should have its own texture map. Oh, I hate doing that.
Oh wow, you really...
Sorry, I'm rolling my chair over my power cord. Alright, thank you. I need to like set up something somewhere that works better than this. Alright, so if we hit pause and start looking at our planets, they're all going to have a similar, well, they're going to have different colors, but they're going to have a similar color scheme because of the texture, the thing we're using. But so we've got this moon here, and this moon looks like it's a moon, although we have the resolution set real low. Hold on, let me fix that real quick. So let's go to our planet and moon and set the resolution to 512. Actually, let's go crazy. Who cares? We'll see how Who care? See how much this locks up my computer.
We should see if there's any questions.
Yes, we should. Oh, this may have been a bad choice. Hopefully we're still streaming. Let's see if there's any questions.
It's rolling maximum moons and planets now, too.
It is supposed to be black and white, yes.
It's black and white because the bytes are all the same on the purlin noise that we're passing.
Yeah, we want it to be black
That
and white
makes it
because
grayscale.
we're actually we're going to be feeding in a lookup table. Okay, so it actually did finish generating, but you can see where the speed now actually is noticeable because that took a while. Let's look at our planets. So here's a planet. That's cool. I kind of like the spots that we're getting, but I also don't like that we're getting them. I know that sounds stupid, but like it kind of looks planety, but it irks me that that's happening.
Craters.
Yeah, or storms or something. I don't know. So that planet definitely has a different looking texture. Oh, we are using the. I must have changed planet texture permanently. Let's actually switch it back to. So in our materials, planet texture. I want to switch this back to Pushy Pixels palletized color real quick. So you can see how this actually looks trying to be planets. Now again, this is inappropriate for our moons now, but we'll see what it actually looks like. Oh, I forgot. This is going to take... I should lower that resolution. Or we could spend some time actually optimizing things. I guess that's another thing we could do. See how much faster it would be without a list or with something else. So, planet. So now you can see we've got, like, now the texture looks real interesting because we're seeing, like, the shading here. If we make it flat, uncolored, you can see the colors come through here. What we'll probably end up doing in a final version is we'll either be generating this texture as well, or we'll have a set of textures to work with. Probably the latter will look better. So that way we can have like Earth-like planets and like gas giant-like planets, and we'll have a different color range for each of those. But yeah, so we can see that that's working. It looks like we've got variety in the texture maps and all these now. That actually is creating some cool stuff with the palletized stuff thrown in there. I did not mean to go to ISO. Yeah, we got some cool looking planets, and the moon should look a little bit different. So if we get some moon action going on, the moon should have much more cratery looking appearance, and they do, because we have the zoom cranked on those, cranked down rather, or cranked up. Yeah. So yeah, now we've got variety of textures. Now the cost of this right now is draw calls. Each of these now has their own shader. It has their own material. If you click on these, you'll see that it says Planet Texture Instance. That's because we made modifications. We actually were doing this anyway, even when we were just doing the tint color. But it means that each of these planets has their own draw call. We're not getting any batching whatsoever on our planets. We may explore figuring out a way to actually do it in such a way that we don't have to make changes to any of these values, and instead build the values into the shader somehow, and that way we can actually lower our draw calls. But I'm not prepared to actually do that on this episode, obviously, and certainly not in 4 minutes. But yeah, so if we click on these, we actually can see the texture maps here. That might even be better. But yeah, you can see the texture maps, and if we click on like a moon, it should be much tighter. Yeah, see how it looks just like pixel noise. So yeah, that's working. That's cool. We did some manipulation stuff. I like that. Let's look at optimizing just a little bit. I'm just curious how much faster it will be if we don't use a list. So I'm going to time this out, actually. I'm going to do the silly thing and just... Actually, I'm going to check for questions real quick first. Ken Perlin is the guy behind Perlin Noise. He won an Oscar for it in the original Tron. I actually did not know that. I knew Ken Perlin. I didn't know that he had worked on Tron. That's very cool. Cookie cutter effect for light. What was that cookie cutter effect? I don't know. I don't know what that context was. Google Unity Light cookie. Oh, I see. Light cookies. Ah, I see. So you're doing like projections and stuff. What are we making? This is awesome. Hey, Jeremy. All right. Nothing huge. That's no moon. Yeah, no, that's no moon. It's a texture map. All right. So random texture. So let's see if we can make this a little bit faster. What I was going to try first is let's just do. So let's try it without the list. So we're going to do it instead of a list. We're going to use an array. And so on this one, we're actually creating a list here. What we'll do instead is we'll do a color 32 array. Actually, I wanted to time it first. Dang it. Let's do that. Do I have any on-screen timers? Probably not. Actually, I know what I can. Oh, no, I can't because it's running. It's frozen when it's doing that. I'll just count it out. All right.
Well, it's going to generate.
1, 2, 3, 4, 5. Oh, it's going to be variable based on the number of planets, too.
Yeah, but can't you use time.realtime since startup at this beginning of start and then time.realtime since startup at the end of start and subtract them and put it in a debug log?
Yes. Yeah, we could probably do that.
And we'll see about how long it takes per moon and per planet.
All right. Let's... I'll do that while this is going. So, start, what we're going to do is debug dot... Actually, what we'll do is float time equals time dot real time since startup. And then we will do debug dot log time dot real time since startup minus time. Oh, fatal error. Ran out of memory, I think. Yay. Did I make any changes to... Nope, it was all prefabs. Yay. Although, ooh, those changes probably didn't save. Let's find out what happens. Force quit. Die. I said die. Thank you. Thank you for dying.
Pixels aren't toys.
Yeah, evidently not. Alright, let's go to our scene, solar system test. Let's see if we go to our prefabs. Do we break these in any significant way? Nope, we just lost the random texture on there. So we'll just go to both of them, add component, random texture, and we will change the resolution to... I'm going to just do 512 for right now. And hopefully...
And scale.
And scale is that gets set by the other thing. So.
Oh right.
So if we hit play here. All right. So it's taking about what 0.04 seconds, 0.03 seconds per planet here.
Approximately.
Yeah. This is at 512. It was
Scrub
taking more for that on the other one, but I don't want it to crash again.
Yeah, 0.035 to 0.04.
Let's actually try it just one more time. I'm going to save scene and save project first this time. That's not what I wanted. Save project. And let's change the resolution back to the crazy 2048. And we hit play. And hopefully it won't crash. And hopefully we'll get some numbers.
So
it claims, yeah, half a second each. So, all right. So let's see what happens.
Do another time. Do the debug log before text.apply because I'm pretty sure that takes a lot of time, especially if you're doing a large texture. So there might not be much we can do.
Let's find out
actually.
Then.
And just take that out, the last one out.
Okay. I was just going to leave it in there so that we could compare.
But the debug log takes time of its own.
Okay. Good point. So we're hoping that these numbers will be significantly lower. Or we're not hoping for that, actually. We'd rather them not be lower, because then that means we can fix things. Yeah, it's not taking that long. So it's we're definitely burning the time. So.
Well, it is taking...
It's taking like 0.5 of a second. That's not I mean, it's time, but it's not a huge amount of time. Most of the time is spent in our calculations. So let's see if we can make these calculations a little bit less hairy. So as I said, we're going to do this as color 32 array colors. And what we're going to do is this array is going to be size... oh, wait. We do it in the new command, right? New color 32. And the size here should be resolution times resolution. So that will create our color array. And then our color array, all we're going to do, instead of adding, we're going to create another variable called int I. I'm going to create this outside of these. Int I equals 0. And then what we're going to do is I++ at the end there. And before we do the I++, we're going to set colors I equals color. And then finally, we don't need to do the to array. We need to do colors. Let's see if this speeds it up any. So these are not exactly the values we were looking at 0.5s basically. So yeah. We'll see what we'll look at this point.
Do you predict it will make much of a difference?
I don't know. I honestly don't. I think it will, but I'm not holding my breath anymore considering how long the beach ball's on my screen. It'd be funny if it was slower somehow. There's also the possibility that doing this test multiple times... well, there we go.
It probably was just generating too many planets that time.
Either that or it just can't do it more than like 3 times for some reason, which is also possible.
Maybe it still has the data.
Alright. Now that we've crashed Unity twice tonight... Oops, that's not the level. That loaded way too fast. Made a huge difference in time. And it did actually make a huge difference in time. Did that really... Are my settings right? Pause. I don't believe my settings are right because that was way too fast. No, it does look like a high-resolution texture map.
It ran for each of them.
Alright, let's try it one more time. Alright, well, orders of magnitude then. So yeah, avoid lists in this scenario. That's wild. That's wild. Because we don't need that. Alright, so yeah, let's not do lists for things that we know the size of ahead of time, which we do on this one. So
does that mean if we keep playing and stopping it, it'll still crash because we're still using all that memory?
Let's find out. So if we do it one more time...
It will just crash faster?
It's getting slower each time. You can see that. No, maybe the crash isn't memory related. Maybe it's just something else. I mean, it's definitely creeping up somehow here. So, all right, I'm done. I don't want to. I'm gonna quit Unity actually before we crash it. I'd say that's the wrap. Let's call that a wrap. So I'm going to go ahead and go into Perforce. And we're going to go into with Unity Perforce. Got too many Perforce servers. And we're going to right-click and choose Reconcile Offline Work. Reconcile. And so we didn't change many files this time, but we did get some good stuff done. So we made our random texture CS. That was the majority of our work. We modified create solar system to actually change variables in this. And we modified our moon and planet prefabs to have the random texture, and we modified our level. That's probably just BS data, but whatever. So submit random planet textures purlin noise for the win. Also arrays FTW. So, I'm going to switch it to the camera, but I'm going to discuss something real quick. So, the reason that lists are slower than native arrays is because there's a few different reasons, but the main thing is the difference between an array, and the reason why I would say that I was being lazy and using a list, is an array is a set size, and if you want to resize it, you basically have to blow away the array and create a larger sized one. And in lists, they're not a set size. You can just add things to them ad hoc. But internally, it's actually still using an array somewhere, and internally it's still blowing away an array and creating a new one with a new size or appending to that array in some magical lower level thing. And so that's the reason there's such a huge speed difference between the two. Generally, you want lists for things that you don't know the size ahead of time, or if it's something that you're trying to track. And generally, you don't want to use lists for very large things or use them a lot. We use them a lot on the show for things that they're appropriate for. This was not one of the appropriate cases. This is definitely a more appropriate case for an array. So anyway, thank you guys for joining us tonight. I hope that you enjoyed yourselves. I certainly enjoyed myself. If you have any questions, please email me at pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. I usually announce my show on there too, so if you follow, you'll get show announcements. Additionally, if you subscribe on YouTube, you'll get show announcements, I think. That's a little bit more nebulous on my end. YouTube just does stuff, so I don't know exactly how it works.
You should buy Phil's game.
Yeah, buy Phil's game, Robot Alone. It's on iOS. It's fun. You should buy it. It's like Puro from WarioWare. I think it's a little bit better than Puro. It's not better graphically than Puro, but it's the gameplay is more interesting because he has like bombs and different things that do other stuff, and his scoring is a little bit different.
Any news on coasters and stuff?
Oh, geez, yeah. Okay, so I told everyone that I'd totally have those shipped out last week on Wednesday, and they didn't get shipped out. It will be Wednesday now. I'm gonna see if I have time to do this tomorrow. I again got absorbed by work. That's part of the reason that we didn't have a show on Thursday, but I was busy on Wednesday night as well, and Friday night. It's gonna be soon. I've got them all printed out. They just need to be labeled and shipped. So it's that's just a few hours of work. So I need to come in. I'll see if I can come in tomorrow and do that. And thank you again for your donations. And I'll have those out soon, and you'll have emails as soon as I have them out. And I'll try and get for the coasters. I can probably do tracking information. The keychains are just going out in envelopes on regular mail, so those will just get there when they get there. But the coasters will actually. I'll see if I get tracking information on those. Anyway, thank you very much for joining us, and you guys have a great night.